Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 7 to the power of x is equal to 70. So I want to find the value of x here. So for my solution, first start with 7 to the power of x is equal to 70. Now I'm going to take the log on both sides. So now I have log 7 to the power of x is equal to log 70. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this would equal b times log a. So in the case of log 7 to the power of x, I can move x to the front. So that's going to equal x times log 7, which is equal to log 70. Now log 70, that's the same thing as log 7 times 10. And now if I have something in the form log a times b, this is simply equal to log a plus log b. So log 7 times 10, that's going to equal log 7 plus log 10. Now I'm going to go ahead and divide both sides by log 7. So then these two are going to cancel out, and now I'm going to be left with x is equal to log 7 plus log 10 over log 7. Now this is the same thing as log 7 over log 7 plus log 10 over log 7. So now log 7 and log 7, these two cancel out, so now I'm left with x is equal to 1 plus log 10 over log 7. Now log 10, that's simply equal to 1. So now I have x is equal to 1 plus 1 over log 7. Now what we're going to do is we're going to find the value of log 7. So log 7, this is equal to 0.845. So now I have x is equal to 1 plus 1 over 0.845. So now 1 over log 7, or 0.845, the value of that's going to be approximately 1.18329. So now if I add that with 1, I get 2.8329. So this is my answer. Alright, so I have x to the power of x to the power of 5 is equal to 100. Now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, m and n are interchangeable, meaning this could also equal a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, then this means that a to the power of n times m, this is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we could think of x to the power of 5 as m and 5 as n. So if I switch those two places, I get x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. Now 100 I can rewrite as 10 to the power of 2. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, that's going to equal 10 to the power of 2 times 5, which is the same thing as 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 5 is equal to 10. Now I'm going to take the fifth root on both sides. So then these two cancel out, and now I'm left with x is equal to fifth root of 10. So this is my answer. Alright, so I have x to the power of x is equal to x to the power of 2. So now the first thing I'm going to do is I'm going to divide both sides by x to the power of 2. So now these two are going to cancel out, and now I'm going to be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, that's going to equal x to the power of x minus 2, which is equal to 1. Now I'm going to take the natural log, or ln, on both sides. So now I have ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So in this case, for ln x to the power of x minus 2, I can move x minus 2 to the front. So this would equal x minus 2 times ln x is equal to ln 1. So now, ln 1, this is actually equal to 0. So now I have x minus 2 times ln x is equal to 0. So now this is going to give me two equations. I have x minus 2 is equal to 0, and I also have ln x is equal to 0. So for x minus 2 equals 0, all I have to do is simply add 2 on both sides, and I get x is equal to 0 plus 2, which is 2. So this is one solution. Now for ln x is equal to 0, I'm going to e to the power of ln x is equal to e to the power of 0. Now e to the power of ln x, the e and ln are going to cancel out, so now I'm left with x is equal to e to the power of 0, which is 1. So my two solutions are x equals 2 and x equals 1. So now to check, my equation is x to the power of x is equal to x to the power of 2. So my first solution is x equals 2, so now I have 2 to the power of 2 is equal to 2 to the power of 2. 2 to the power of 2 is 4, so I have 4 is equal to 4. This is right. Now my second solution is 1. So now I have 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1. So these two are right as well. So both my solutions are right. Alright, so in this equation, I have x to the power of 2 over 3 is equal to 16. So my only variable in this equation is x. So that's the variable I'm going to be solving for. And now for my solution, I'm going to first start by rewriting my equation down here so I have more space. I have x to the power of 2 over 3 is equal to 16. And what I'm first going to do is take the power of 3 over 2 on both sides. So now I have x to the power of 2 over 3 to the power of 3 over 2 is equal to 16 to the power of 3 over 2. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So x to the power of 2 over 3 to the power of 3 over 2 is the same thing as x to the power of 2 over 3 times 3 over 2. And this is equal to 16 to the power of 3 over 2. Now, 2 over 3 and 3 over 2, these two are reciprocals, so they simply cancel out, leaving me with x to the power of 1 is equal to 16 to the power of 3 over 2. And x to the power of 1 is the same thing as x, so I get x is equal to 16 to the power of 3 over 2. However, we're not done yet, because we still have to simplify this. 16 to the power of 3 over 2 is the same thing as 4 squared to the power of 3 over 2. And again, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So these two cancel out, and I get x is equal to 4 to the power of 3, and 4 to the power of 3 is equal to 64. So I get x is equal to 64. Now, I'm going to check to see if this is right. So my original equation was x to the power of 2 over 3 is equal to 16, and x is 64. So I get 64 to the power of 2 over 3 is equal to 16. Now 64 is the same thing as 4 to the power of 3. So now I get 4 to the power of 3 to the power of 2 over 3 is equal to 16. Then these two cancel out, so I get 4 squared is equal to 16, and 4 squared is 16, so I get 16 is equal to 16.